Welcome back to Learn with me, Ms. Killen, here at MPB. We are in our 8th unit, our exponential functions, and we are on lesson 2. So let's see what we've got in lesson 2. We are looking at standards FLE2. I can write equations of exponential functions that are represented as a graph and as ordered pairs in a table. So let's go ahead and jump into our lesson 2. So a question. How can functions be represented? Well, we have verbal descriptions, we have algebraic equations, numeric tables, and graphs. So this is just some of the ways that we can see those exponential functions. So let's see what we're going to do with them. So first, let's do some review. Obviously, we've got some type of constant rate. And when we're talking about constant rate, we are talking about our slope, obviously. And we know our slope is our rise over our run. So then we also know that with that slope rise over run, it is linear, those linear functions. We have a steady increase or we have a steady decrease. We are also looking at one input to one output, and that's what our linear function looks like. So then what about this? When we have the verbal of linear, we're talking about a constant rate, this over this, this over this, a constant rise over run. When we're looking at the algebraic equation, we have g of x equals 40x plus 7, where we have that formula of y equals mx plus b, where b is my y-intercept, my m is my slope. We have a table. We know we have our x values, and we know we have our y values. And then we know that it is graphed with a straight line. So that's how we're looking at those linear functions and linear equations. Now, quadratics. We've talked about quadratics, and we know with a quadratic, we do not have a constant rate of change. We are also looking at the algebraic expression of 3x squared plus 230. We're going to have that x squared value in that quadratic. When we're looking at the graph portion, it's graphed as a parabola, where we have our turning point. Also, we're looking at the different zeros that we could possibly have. And then we have our table, of course, 1, and we would have 233, 2, 242, 3, 257. So this is what our quadratic formula is looking like. So now we're looking at this exponential functions. Now, when we talk about exponential functions, we've already dove into that geometric sequencing, and that's going to help us with this exponential function. So a vertical description of an exponential function could be doubles every hour, decreases by half a day, or decreases every half day. Maybe it is every hour it is going up 4 points, or it could possibly look like every hour it's decreasing by an amount. So it is having to look at the point previous to help us find the next point. That's what that description is going to look like. So you think of the change in reference to the previous point, and we talked about that. That is something that we need to make sure that we put in our notes page that is extremely important with these exponential functions. We have to think about the change in reference to that previous point. That's something that we definitely need to make sure that we take note of. Now, I've got a numeric expression, 1, 200, 2, 300. So if I looked at this numeric table, and where I don't see a constant rate of change, but I can see patterns. Now, we talked about algebra being all about patterns. So to go from 200 to 300, I'm adding 100. To go from 300 to 500, I'm adding 200. When I go from 500 to 800, I'm adding 300. When I go from 800 to 1200, I'm adding 400. Well, I see a type of pattern, but when we talk about these functions, we want to know a specific change. So then I would look at my next deviation of changes. So let's look at that. So 100 to 200, I'm adding 100. 200 to 300, I'm adding 100. 300 to 400, I am adding 100. So I can start seeing some of those changes that would go together. Now, we will dive more into this, but I wanted you to see that there are patterns with these expressions and with these tables of exponential functions. So let's look. Now, when we have this graph, let's go back and use this. So we had our x and our f of x, and we had 1 and 200. We had 2 and 300. We had 3 and 500. And we had 4 and 800. And we had 5 and 1200. So let's just go ahead and graph these and see what this looks like. I'm going to graph it up here on the board. I want you to graph it on your notes page or maybe on some graphing paper. And let's see what it looks like. So I'm going to grab another color. Let's do blue. So I have 1 and 200. So I'm going to put that there. I have 2 and 300. I'm going to put that about right there. 3 and 500. I'm going to graph about right there. And then 4 and 800 is going to be about right there. And then 5 and 1200 would have been somewhere up in here. So if I looked at this, it's not a straight line. It's got a curve to it. So we've got to make sure, now you remember Ms. Killen can't draw to save her life, but you can see the curve. It's not going to be that straight line. So that's how our graphs are looking for these exponential functions. Now, sometimes you may see exponential functions that look something similar to this, and then all of a sudden it's a drastic change. Or you have it, let's get another color so we can show a different way of seeing this. Maybe we're coming down, then all of a sudden. So there's multiple ways that these exponential functions graphs can look. So these are just a few examples, but I did want us to make sure that we are noticing they're not straight lines, they're not parabolas, they've got a slight curve depending on if they're increasing or decreasing. All right, let's go to the next one. It says exponential functions. An algebraic equation. Use the following steps to write the equation from the exponential functions. Now, on your notes page or on paper that you're taking notes, we want to make sure that we are writing these down because these are going to help us when we get more into the topic. So let's go ahead and see what we've got. Steps to write the equation of the exponential function. First, we're going to use our y-intercept and where x equals 1. That's just what we're going to use. It says pick 2 points. The easiest are these, and so that's what I said. You can use any points on the graph, but the easiest, we're all about the easy, right? So the easiest would be where I have my y-intercept and where my x equals 1. No problem. So then it says sub the coordinates into the exponential equation, then solve for a and b, sub a and b into the equation. Now, you're probably sitting there going, a and b, what? We got x and y and a and b? Okay, so this is the easiest way to think about it. My y equals. We've all seen that. So now we're going to have a times b to the x. So when we use these 2 points, we're going to, everywhere we see an x, put the x value. Everywhere we see the y, put the y value. So that's why we have y equals ab to the x. Noting, and then we need to put this note, this is my y-intercept. That should help. And then this one is my common ratio. And that is also noteworthy. We want to make sure that we've got all these different pieces of this formula. All right, so let's look. So it says use previous points to create the equation for the solution. So let's go ahead and do that. So I have my y equals ab to the x. We're using 0, 100. Because that's what it told us. And then we're using 1, 200. Now, let's go back a slide. Make sure 0, 100, 1, 200. So, yep, there's where we're at. So then what I'm going to do is I'm going to solve for my a and my b. So I'm going to use this one first. So for me to do that, let's change colors. I'm going to do it in green. So let's do this one in green. So I have my x coordinate and my y. So I have 100 equals a b to the 0 power. See how I plugged in my x and my y values where I saw my x and my y. X was 0, y was 100, so I plugged them into the equation. So let's work it and see what we get. So then anything to the 0 power is an understood 1, or it is 1. So I'm left with a equals 100. So now I know I have y equals, and then we've just found out that a is 100. So now let's solve for b. So for me to solve for b, let's use orange. So I'm going to use orange here with my x and my y value. So I'm going to do it again. So I have y of 200 equals, we have 100 because that's what a equals, times what? B to the 1. All right, so I've got to get that b by itself. Anything to the 1 power is itself, so it's b. So I've got to get that b by itself. We've been doing this ever since we started with variables. So let's get that b by itself and see what it equals. So here we go. Since I'm multiplying a and b, I'm going to divide on both sides. So b equals 2. So then I'm going to have 2. Then I can finish up. So there is my equation, y equals 100 times 2 to the x. So I took 2 points from my exponential functions graph, took those points, plugged them in to this equation, y equals a times b to the x, and found the whole equation for that graph. So that's how we're using the process. So let's look at another one. Let's do some more practice. In the next couple of slides, write equations from the different tables and graph. All right, so here we go. The table demonstrates an exponential function. Write an equation using the function given. So the first thing I'm going to do is write my equation. Y equals a b to the x. Now, we've already said that it's easier to use my y intercept, and it's also easier to use my 1 where x is 1. So let's go ahead and plug these in and see what we get. So I have my, let's do the red color. So I've got 325 equals a b to the 0. We talked about anything to the 0 power is 1. So a equals 325. So I'm going to go ahead and plug that in. Y equals 325. Now let's solve for the b. So I'm going to use 315.25 equals, well, I know it's 325 is my a times b to the 1. Anything to the 1 power is itself. So I'm going to get b by itself by division. All right, so since I use that division, I have b equals 315 over 25 divided by 325. So then I can rewrite this as y equals 325 times 315.25 over 325 to the x. And we've taken 2 points, we've plugged it into our equation, and now we have the full formula or the full equation for this table. Good job. Now this graph demonstrates the same thing. So I'm going to let you work on your paper as we work the graph up here. See if we get the same thing. Let's work it together and see what we can get. All right, so this graph demonstrates the exponential function. So where my y is intercept, I'm going to say it's about right there. And then where my 1 is, I'm going to say it's about right there. I would say that this is my 325, and I would say this is about 315. So let's go ahead and work this. Y equals ab to the x. So I've got 0 and 1. So I've got 325 equals a b to the 0. We know that's going to be 1. So then I have a equals 325. So now I'm going to do my other one in a different color. So let's have 315 equals a, which is 325, b to the 1. Anything to the first power is itself. So then all I'm going to have to do is get my b by itself by division. So my b equals 315 over 325. Now I'm going to pretty this up. So I'm going to turn this into a decimal. So when I write this, I can write y equals, and it's going to be 325 times 0.97 to the x. Check your work, check my work, see if we got the same thing. Did you get the 315 over 325, and then when I turn that into a decimal, did you get that it was 0.97 repeating? So we're just going to use the 0.97. All right, so let's go to the next one. Both the table and the graph show the exact same thing, which we've seen in our work. So if we ever have a problem with the table, we can always put that table into either Desmos or our calculator and pull the other to make sure that they are the same. All right, so here's problem number 2. Use the following table and graph to write the equation for each scenario. So let's see what we got. So I have a table and a graph. Write an equation. What type of real-world scenario could this data represent? So I'm going to work it up here on the board. I want you to work it on your paper, and let's see what we get. Here we go. So the first thing I'm going to do is I'm going to write y equals ab to the x. So I wrote my equation. I know that I'm going to use this point and this point. So let's see. I have my x and my y value. So I'm going to say 4 equals a times b to the 0. I know that's 1. So a equals 4. So y equals 4 times. So now I'm going to solve for b. So I have, let's get a different color so we can just have the different ones. Let's do blue. All right, so then I'm going to use my 2 equals 4 times b to the 1. Anything to the first power is itself. So I need to divide to get that b by itself. So b equals 1/2. So I can put 1/2 there. So my equation is y equals 4 times 1/2 to the x. And if we look over here, 0 at 4, 1 is about at 2. So if I worked from the graph, I would get the same thing. You've just got to be able to make sure that you can see where it crosses the y axis and also where that 1 and whatever the 1's y value is equal up. All right, so let's look at the next one. It says, now that we have written the equation from pencil and paper, let's use our calculator to see if our assessment was correct. So let's go ahead and pull this up. All right, so the first thing we're going to do is we are going to put the table in our calculator. So I want everyone to make sure that we are watching and taking notes on how to plug things into our calculator. So the first thing I'm going to do is I am going to put a table in. So I'm going to hit my stat button, which is right beside my cursors. So then once I hit that stat button, I'm going to hit number 1 to edit it. My L1 and my L2, that's like saying L1 is my X value, L2 is my Y value. So I'm going to go ahead and put the table in that we just got. So I have -1 equals 0 equals 1 equals 2 equals. Now I'm going to scroll right and put my y values in. 8 equals, 4 equals, 2 equals, 1 equals. All right, so now that I put my table in, I need to go back and pull my exponential regression. So second step, to pull the equation, I'm going to go and put second quit. So I go back to my home screen. Remember, second quit always goes to your home screen. To pull my equation, I'm going to hit my stat button again. I'm going to scroll right to calculate. Then I'm going to scroll all the way down to my 0 where it says EXP reg. So I'm going to press enter. My x values are going to be L1s. My y values are going to be L2s. So I'm going to scroll down till I get to calculate. And I'm going to press enter. Now, there is my equation. Y equals a times b to the x. It's telling me that a equaled 4, which it did, and b equaled a half. So now, not only are we able to do it on paper and pencil, now our calculator's enabling us to put the table in, and it gives us our equation. All right? So let's go and see what we have next. So it's time for you to master. What I'm wanting you to do is I want you to look at each one of these. Plug these into Desmos, plug these into your calculator, and see which one of these exponential equations go with the different graphs. You do it, you and your table partner, see what you get, come back to me, and we'll see if we can get the same thing. All right, so now that you've worked, let's go ahead and see if I can get the same thing that you did. All right, so I'm going to go over here. So I see right here that my y-intercept is here. I have my y-intercept at here. And then I have my y-intercept here. So let's use some context clues that we know about these. Now, I have y equals ab to the x. This right here is my y-intercept. This one is my common ratio. So my y-intercept would be my a value, or in the a's place. So let's see. Right here I have a negative something. Negative. So then what could that one possibly be? What about this one? Right here I have positive and I have positive. So I can use those context clues to kind of help me along with that. So the easiest way, if we can't use those context clues, is to go to Calculator Desmos. So let's put that first one in our calculator. So we go to our y equals feature. And in our y equals feature, we are going to put 2 exponent key x and hit graph. When I do that, I notice right away this one is my answer. So then we know what that one is. Let's try the middle one. So I'm going to go back to my y equals feature and put that middle one in. So I'm going to put -3 exponent key x and hit graph. There you go. All right, so Ms. Killen, obviously the last one is going to be the bottom one. You always double check. Better to measure twice and cut once than not have enough to do. So let's go ahead and put that in. So I've got 3 times 2 exponent key to the x, and there we go. So we see how we can use our context clues. We see how we can use that y equals feature. And then we've also seen how we can put a table in to get our equation for this exponential functions. Something that we want to remember and not forget, exponential is different from linear and even quadratics. You can see functions represented by verbal descriptions, numeric tables, algebraic equations, and graphs. And the formula that we just used and just learned is y equals a times b to the x. I am so glad that you came to learn with me here, Ms. Killen. is so excited that we're in this exponential functions unit. I want us to have a great time with this, and I want you to have an even better day.